Hello friends, I welcome you to my this representation. Okay, so in today's video we are going to look at science paper 1 2023 GCE. Specifically it is question B 6 from section B. So the question reads, figure B6.1 shows a ray of light traveling from glass to air at an angle. The refractive index of glass is 1.52. So we have a semicircular glass block and also the ray of light. So the ray of light here is the incident ray. Okay. So the first question, which is question A, is saying define critical angle. So now, what usually happens here is that when you increase the angle of incidence, the angle of refraction also increases. Now, there will be a point where the angle of refraction will be 90 degrees, like this one here on the diagram. Okay. Now, the angle of incidence is going to become the critical angle. So here I'm going to say the critical angle is the angle of incidence when the angle of refraction is 90 degrees. So the next one, which is B. B is saying calculate the critical angle in figure B6.1, 2 marks. Okay, so now on this part here I was saying the critical angle is the angle of incidence when the angle of refraction is 90 degrees. So on this part here, I'm going to say sine critical is equal to sine angle of refraction over the refractive index. Now, since here I'm saying the critical angle is the angle of incidence when the angle of refraction is 90 degrees. So on this formula here, I'm going to put 90 on the angle of refraction. So I'm going to say sine 90, then the answer is going to give me 1. Okay. So our original formula that we are going to use to calculate the critical angle here is going to be like this. Sine critical is equal to 1 over refractive index. Now, since here we are finding a critical angle, we need to make sine this sine the inverse. Okay. So here I'm going to say the critical angle is equal to sine inverse. Open bracket 1 over refractive index. Okay. So now on this part here, the refractive index here it is 1.52. So the refractive index is on the question here, on the first question in the statement. Okay. So when you divide 1 divide 1.25, we are going to get 0.66 like that. Okay, so I have rounded it off. Okay, so now I'm going to say the critical angle is equal to 41.2, or we can say 41.1 degrees. Okay, so let's move on to the next one, which is question C. So question C reads, state 2 conditions for total internal reflection to occur. So now, what you need to understand is that for total internal reflection to occur, the angle of incidence should be greater than the critical angle. So here I'm saying the angle of incidence should be greater than the critical angle. Apart from that one, we are going to say the ray should move from high dense medium going to the less dense medium. Now, on this part here, the glass block is going to be considered to be high dense medium, and air is going to be considered to be a low or less dense medium. Okay, so those are the answers for question C. So let me repeat. I'm saying the angle of incidence should be greater than the critical angle. Then the last one I'm saying the ray should move from high dense medium going to less dense medium. Then the last one, which is question D, is saying give one application or use for total internal reflection. So here I'm going to say total internal reflection is used in optical illusion, or I may say optical cables. The last one I can say, total internal deflection is used in optical mileage. Okay, so that was the last one. Remember to subscribe and share the video. See you next time.